Tēnā koutou katoa. It's my great pleasure to introduce Professor Carole Goble to us today. Carole is a Professor of Computer Science at the University of Manchester in the UK. She's been a leader in the e-science community and in the UK and internationally for a long time. Tools like My Experiment and Taverna are down to Carole and her team. She plays a key role in 11 large Horizon EU projects. This is an amazing feat in itself, but made even more amazing by the fact that the UK bailed out of EU science projects a couple of years ago, I think except for Carole, who's now responsible for the GDP balance of finance with the EU, helping to keep the UK afloat. Carole, there's more to Carole than this, though. Carole is the kind of person who has an open table. She invites people in, connects people together, enables others to succeed. Scientists can be rather self-centered and inward-looking sometimes. Not Carole. She's on first-name terms with the AV guy here, who she met 5 minutes ago. That's the kind of warmth and kindness that Carole brings to the research that she does, to the people whose lives she touches. I first met Carole in 2003 at the Semantic Web Conference in Florida. She was a force. I remember one of my grad students bursting into my office after we'd met Carole at that conference to tell me in an out-of-breath kind of way that Carole had just cited his research, and that made his year. It was a big deal because Carole is a big deal. So it is my great pleasure and honor to introduce Carole to us today. Thanks for being here. We look forward to hearing what you've got to say. Thanks, everyone.
Wow, I wish I'd got my husband out of bed to hear that, because that was better than his wedding speech, I can tell you that. So hello, I'm Carole, and I'm going to be talking about handling health data, and we heard quite a lot about that yesterday. We had a very nice BOF from Yvette led, and I'm particularly going to talk about how we use something called research objects, which I've been working on for quite a while, in trusted research environments. And hopefully I'll be able to squeeze in the talk. I've been up since 6 trying to remove slides. Let's see how that goes. I want to start here with a report, the Goldacre Review. Has anybody read the Goldacre Review? No. Oh, 2, yes, the usual suspects. The Goldacre Review is an excellent report. It's all about efficient and safe use of health data by Ben Goldacre, who actually runs Open Safely in the UK, which is a kind of a trusted research environment. And it's really about thinking, how do we make the best use of our health data for research going across geographical and governance boundaries? And I'm particularly interested in across borders in Europe. As you just heard, I do a lot of European projects, and I kept in with all the European guys when the rest of the government didn't. And we also have a very devolved healthcare in the UK. The key point, of course, as we discussed yesterday afternoon, was clinical data, health data is highly sensitive, it's personal, it's confidential. There's a difference between sensitive and confidential data, but I don't want to go into that classification just yet. But it can still be fair. So fair is findable, accessible, interoperable, reusable, but the A isn't open, the A is accessible. That is explicitly for that. So you can still get access to it, it's just restricted access. So that's what we're going to talk about. And I'm going to do this in the context of 2 organisations that I'm in the leadership of. The first is Health Data Research UK, which I'll introduce a bit more in detail, which has a spin-off called DARE UK, which does innovation and sort of early development research in the areas of federated analytics in health data and so on. And Elixir, which is a European research infrastructure for life science data. So let me just explain a little bit what those are, and I'm going to top and tail the talk with Elixir. So Elixir Europe is one of these things called a European research infrastructure. And this is actually for federating digital infrastructure for life science data across 23 countries. Actually, it's 25 countries now because we've just let in Romania, I think it is, as an observer. That's about 240 organizations that we attempt to wrangle in order to be able to create fair data, fair software, and open as possible, and enable transnational access to that data, including sensitive data. I'm head of node of Elixir UK, which is the UK node, and my organisation has 28 organisations within it. So UK universities, institutes, not-for-profits, and so on. And the UK runs a lot of the flagship services of Elixir. We run the training portal and the workflow registry and so on. So this is an exercise in people wrangling as much as anything else. So the kind of things that Elixir does, and I'll mention a few of those later on, but from the point of view of human genomics and translational data, I would put it into these three sectors. We do human genomic data, so we're part of this big European genomic data infrastructure effort. We do things around disease missions, so around cancer and around infectious diseases and around rare diseases. And we also increasingly going into health data, the European health data space, Healthy Cloud, and so on. And we're very much a partner in the Global Alliance for Genomics and Health. But I'm going to mainly talk about Health Data Research UK, which is actually, as a very large organisation in itself, a member of Elixir UK. And Health Data Research UK is set up as a national organisation to unite the UK's health data, to enable us to be able to make some research efforts out of the clinical data that we collect routinely. So this is Health Data UK. Now, there are 67 million people in the UK, which is a bit bigger, I understand, than New Zealand. In fact, I think London is bigger than New Zealand, actually, when I think about it. Anyway, so we've got a lot of people and a lot of activity in the national arena. All these different organisations are part of the data ecosystem in our health data. So we've got biobanks and cancer banks and so on. So we have a very decentralised health data landscape, just like Europe is a decentralised health data landscape by dint of it being different countries. So we have consented data, which is research cohorts, but we have a lot of unconsented data that is collected through routine healthcare, through GPs and hospitals and lab data. And we need to access this for research via what we call trusted research environments. And I don't know if that language has come out to New Zealand, but that's the language that we're using at the moment. And we have these trusted research environments at all levels, at the national level, so we have the England and Wales, regional level, at institutional level, at project level, all sorts of levels. Now, trusted research environments are also called, confusingly, SDEs or safe havens, or yesterday, I think Yvette called them a secure research environment. Where is she? Yeah, secure research environment. And I think this is also what Richard Sinnott was also talking about yesterday in his talk. Is Richard here? Hey, there he is. Yeah. So this is all about the data and analytical tools are all in one place in a highly secure computing environment. And you provide remote access to that health data for approved researchers only to that data in order to be able to do their research. And in fact, approved access to the data and approved access to the analysis as well. Now, the NHS England has set up a secure data environment network. This has 11 trusted research environments, which they call SDEs, just to be different. Of course they do. The whole idea here is that you don't have access to data in any other way than through a trusted research environment, through this controlled environment with safe, secure transfer. So how do these work? Well, it's an airlock system with a lot of gatekeeping. So there's be a data repository that will have where you've done all the linkage and curation and anonymization and I think, I can't remember what Richard called it, I don't know, munging, cleaning up, lots and lots of management around the data itself. Then you have the actual analytical environment, the virtual environment that is on a per project basis. So this is a set of anonymized data will go into that environment that has no internet access, it's completely controlled. That is what your researchers are actually going to use in order to be able to do their analysis, do their querying, and do their, investigation. And then out of that will come a graph or a table of summary results. So at no point do you get any kind of row data that's associated with a particular patient. So it's all anonymized. And this disclosure control checking process is actually largely manual to this at the moment. I'll go into that a little bit more. And out comes this anonymized data that can be exported typically as a spreadsheet. That's how it is done. So this is a very restricted environment, and it follows the principles of something called 5 safes, and I'm going to go into that a little bit more. So an example of a kind of analysis we wanted to do is this recent study that's just been published, which is about under-vaccination on COVID in the UK. And this is a research study of 67 million people, which is the first time we've managed to do a kind of completely, across all 4 nations, study across other medical records. But it's an incredible piece of artisanal kind of crafting to do this. Okay, so first of all, you have to request and justify permission to access each of the fields in each of the TREs that you want, the variables that you want to get access, and that's not going to scale typically. Each TRE presents a predetermined stock environment that they will have you analyze in. You know, the environments that, are they running Stata, are they running Python, are they running R, what kind of data is it files, is it SQL, what kind of stores are they using? And that's incredibly challenging from the point of view of reproducibility. It's incredibly challenging for any complex analysis. Actually, this analysis for this paper was incredibly simple, but nonetheless, it's really hard, and here's the secret, to get hold of the analysis that they really did, even if you go to the GitHub, because it's not documented. And then there is access to row data, which is, now I'll go into this a little bit later on, but Ben says we should not have access to the actual data itself. We need to have code that will touch the data, not eyes that touch the data. Because at the moment the standard is there's privileged, trusted researchers, and that's the trust bit of the 5 safes of people, are given direct access to the data. It's anonymized, but direct access to the data. And the safety for that is based on a handshake, basically. And that doesn't scale. It's not democratic. And where is the trust on this? So if you read this paper, you'll think, who are these authors? And the authors are some of the great and the good, because they have access, and all the TREs owners, because you had to get their permission to use it. So that's an interesting setup. And if we're going to scale, we need to do a bit better than that. So the 5 safes framework basically says one has to think about safe data. So is the data treated so that it's not going to reveal confidentiality issues? So that means it's anonymized and so on. Is the project approved by the data owners? So that's the TRE. Are the people trained? So who are the people? Do you trust them? And are they authorized to use this data? The setting is, what is the secure lab environment that you're operating under so that it will prevent unauthorized use and no leakage? And the outputs, are the outputs screened and approved so that they're non-disclosive? That's the whole point about 5 safes. And it's a governance process to authorize specific people for a specific project, for a specific bit of data, for a specific safe setting, highly managed disclosure. And the review is usually of, is something allowed to go in? Are you allowed to access this data? and is this data allowed to exit the TRE, is typically 4 I's, which means manual. Somebody looks at it, and that is not terribly scalable either. So what about FAIR? Going back to FAIR. Do FAIR principles and 5 safes go together? Well, for sure. But if we really look at the state of the art at the moment, if we look at the alliance of data hubs that are, allied with HDR UK, 80% of those alliance members don't even have any kind of application form on their website to be able to get access to the data. So that's not very findable. So we've got quite a long way. Before we start doing machine processable metadata, actually just sticking a form on the website to tell you how to do it would be a good start. And here, one of the words I want us to flow through this talk is transparency, making it much more transparent. How do you get access, and what did you do in this whole process? I also wanted to point to this, which is quite interesting. This comes from Africa. And Africa, the Vodon network in particular, which was set up during COVID, has developed this notion of federated FAIR principles, or FAIR OLR, which is fair, but with ownership, localization, and regulatory compliance associated with it. And I think this is very important because African data sovereignty is a really hot topic. And so this is something that they're following up. And you may be, if you're interested in sovereignty, this might be something to look at. Okay, so how are we doing this in HDR UK? How can we be better at being fair? Well, we can make the data sets more findable for a start. That would be good. And so we've set up this Health Data Research Innovation Gateway, which currently has around 845 data sets. And we also have a data usage registry. So if your data is used, that is registered as well. So you can see what data has been used for which projects. And that's an important piece of transparency. Another thing we've been working on is making data sets interoperable. And for that, we're particularly banking on, amongst many other things, OMOP. So we're adopting the common data model there. And that's one of the primary approaches in the Europe, actually, the EDAN world, is moving towards this common data model for observation data. But the thing I really want to talk about is federated data analysis. So we can't keep up with the current situation that we have at the moment, which is one researcher has a trusted relationship with one data custodian in one TRE, and they do their analysis with that, and it's all handshake and manual. That simply doesn't scale. And how are we supposed to do that big pan-UK analysis that doesn't take 3 years to do it and an awful lot of chicken dinners, which is what you basically have to do because you're buttering up and chatting to people over dinner to say, can I get access to your data? All right, that's perfectly all right because you're from Oxford and so that's okay. So that's kind of how it is, right? I hope this isn't recorded or certainly not sent to Oxford. Anyway, so we need to be able to federate. We need to be able to have many-to-many trusted data custodian and researcher relationships in order to be able to mature this. So the revolution has become inevitable that we're going to have to go to a federated architecture. So here I'm going to talk about federation from 2 aspects. There's 2 broad ways one could do it. You can pool, which basically is aggregate data from multiple sources, put it into a TRE, link it all up, and then the researchers remotely visit the data, run their analysis in the TRE, and then download the result. And I think that's what you're really doing quite a lot of, isn't it, Richard? Yeah. Yeah. And another way of doing it is in situ federation, data, if you like. So here, data remains in situ within the controlled TRE. The researchers remotely visit the data. They run the same analysis in each site. They get the results back, and then they can aggregate the results there. So there are 2 different ways of, it's just where you put the aggregation, where you put the work. So I'm going to talk about the second one in particular. How could we really improve that second going to visit different TREs and getting your results back? How could we make the analysis across multiple TREs less painful than it already is? Because at the moment, if you take some federated analytical tools like Bitfont, which is a company that specializes in machine learning over health data, DataShield, many of you will have come across DataShield, which is a very popular R-based federated analysis platform, lots of others. And then we have lots of TREs, lots of trusted research environments. The Sale Databank is the Welsh one. Treehouse is a Scottish one that's based on AWS. Pioneer is one based in Birmingham, based on Azure. Sale is an on-premise system. So there's lots and lots of them. But each TRE has its own bespoke solutions for exchange, own tool environments, spun up for the analysis, often quite simple analysis, actually. Each toolkit has its own unique exchange standards. So basically, you end up with this spaghetti. How can we improve that? Well, we can streamline plumbing. And that's mainly what the Triffics project that I led with Phil Quinlan, who is my co-lead in Federated Analytics in Health Data Research UK. And this was funded by the DARE UK programme to see, could we actually standardise or try to streamline this? So we took two views. Let's try to standardise and streamline the flow of metadata that goes around this to operate the 5 safes. Because 5 safes is all about metadata. It's all about who is this and what are they trying to do and what is the project. So it's metadata. And then the second thing we could try to do is to simplify the data visiting code execution. So we would try to use some modern reproducible analysis techniques that would handle much more interesting things than just simple stata analysis. And also bear in mind that Ben says no eyes on data access, even for privileged researchers, even if you're from Oxford, you're not. It's code only. And that's how Open Safely, for those of you who know Open Safely works, is code only. You don't actually see the data. What you have is the code, and the code sees the data. So what technologies would support off-eyes analysis pipelines? I know computational workflows, because I've been doing those for 20 years. And if you've got a hammer and a nail, just keep hitting it. So here we are, computational workflows. And for many of you will already be aware of these, multi-step processes for data analysis. They help automation, they do scale up, they support provenance, and there's currently 352 workflow platforms, to my knowledge, and probably 353 by the end of the day, because people do like to build workflow systems. The ones we mainly use in Elixir are Nextflow, Galaxy, SnakeMake, Common Workflow Language, and Jupyter Notebooks, which is a kind of workflow environment, sort of, and of course Docker and containers for the tools dependencies. So the idea here was we could do remote query processing by running pre-approved workflows that were containerized workflows in the TREs. And then the analysis would be transparent, reproducible, because it's using these workflows. They could be peer-reviewed for quality control, the workflows, not the data that they're analysing, but how they processed things, how they went about the processing. They could be shareable and adaptable and reusable. And we really wanted also to remove the hassle of handling different codes. So if you're running a query in different places, you're going to have to write different codes for the different environments that you're running. So if we had a common way of writing the workflows and then a way of being able to execute those workflows what's technology agnostic for the TREs, that should really help quite a lot with the streamlining. So luckily, Elixir has a shed load of workflow infrastructure that we've been developing over a number of different years, partnering with the Australian Biocommons. Anybody from Australian Biocommons here? We thank you for your service. For example, the Workflow Registry, which is established by Elixir, although it's been built and is supported by European community, I'm the head of the Workflow Registry, Workflow Hub. The product owner is Johan from Australian Biocommons. So we're very intertwined there. And that's for analysis transparency. We can register our workflows there. And we've also developed a number of different technologies for being able to do technology-agnostic execution using GA4GH APIs, particularly the WES and TES APIs. That means that if you've got a workflow in SnakeMake or a workflow in the Common Workflow language or workflow in Galaxy or workflow in something else, this system like Workflow Execution Service, or there's another one called Sapporo from the Japanese, will run the workflow on your behalf. It will sort out how to get access to those platforms and to run them. And there's another one called the TES Execution Service as well. So the second thing we tried to do was to streamline the metadata, standardize the flow of metadata. And again, this has to be platform independent and extensible because we're not working in a greenfield site. We've got lots and lots of TREs already in existence. But we need to be able to support metadata movement. Again, metadata is explicitly presented. We can peer review it. We can support transparency, reproducibility, and all those good things. And so for this, we used RO crates. And we've already heard a couple of times about RO crates. And if you were in Mark's talk yesterday, you'll have heard about RO crates. These are research objects, which I'll go into a little bit more. And so instead of everybody doing a point-to-point, everybody instead generates and consumes RO crates. So it's a kind of common currency of metadata movement. So these things travel around our systems. So what is an RO crate? It's packaging. It's practical and lightweight packaging. Basically, it aggregates files and URI addressable content with metadata, context information, and makes that a machine-actionable, metadata-rich structured archive. And that archive can then journey about. So it's like data moving with metadata, or actually data not moving with metadata, as I'll go into briefly. So that's what it is. And we've been working on this for a very long time. So why is it called RO Crate? Well, some of you may recognize this man. Yes, it's Gandalf. No, it's Peter from Queensland. And what wizardry made it be called RO Crate? Because it used to be called research objects. Well, we had something from, 10 years ago now, called research objects, which were how do you organize and describe such packages with ontologies and RDF and Shekel. It was great. We wrote shitloads of papers. It got massively cited. Nobody could use it. Unless you were a semantic web guru like Mark. But then we had Peter, who had Data Crate, which he built for Cameron Nayland, actually, for those of you who may remember, which was a simple web stack to basically package stuff together. So what we did was we married the two together, RO Crate, hence. So what the rule was, had to add sufficient extra benefits from what already existed. So, all our fancy work on how you would actually organize these objects, but without compromising the developer experience. It was developer friendly. That was important. Because if it was developer hostile, they're going to do their own thing. That's it. And so Peter kept our feet nailed to the ground. So what it is, it's basically a metadata file, which points to some content, and the content could be files, directories, or links to web resources, or links to other RO crates, because they are other web resources, and it uses linked data, so JSON LD and schema.org to do all the metadata descriptions, and it uses standard packaging methodologies like Baggit and Zip to do the packaging. And that's it. So it wraps data and metadata and software and whatever you want, but it's just basically a set of conventions on how to do this. But it turns out a little bit of packaging goes a long way. And Peter made sure that we didn't move away from the going into the exotics. It's mostly a metadata box that's bigger on the inside than the outside. I don't know if any of you are Doctor Who fans. Anyone who's not a Doctor Who fan? You can just leave right now. No. So this is because it can point to external references. So it's got metadata about files that may be internally packaged, but primarily it's also talking about metadata about things that are outside, because it's about linked data. And that includes pointing to workflows in a registry or pointing to data that it can't actually access, but it knows where it is. So you kind of got a knowledge graph on the inside and the outside, and with the appropriate checksumming in order to be able to see if things have changed. So this little bit of packaging goes a long way, is important. So Peter was right. It's infrastructure independent, so it overcomes all those repository and service silos, and so each of our partners, so all of those partners I talked about, like the SAIL data bank and Bitfont and Data Shield, could all implement it. It's really developer, I would say, sympathetic. Let's say that. I don't think anything is friendly, because why would you make software that's hostile? That seems weird. So I don't understand when people say, I've made it user-friendly, as opposed to user-hostile. Well, that's good. So it's developer sympathetic, it's quite low-tech, and it just uses off-the-shelf web stuff. It's not one-size-fits-all, so it's extensible, and I'll explain a little bit how we do that, because it's going to have to be quite open-ended and quite descriptive in order to be able to cater with all the different kinds of things that you can package together. And you have to embrace your unknowns, right? And you can point to resources outside of the crate. And that means it's effectively, you can move a metadata object around our trusted research environments without ever moving the data, because you're just moving the metadata. Okay, so this is wrapping up the piece about RO crates. It's used a lot, so we use it across the whole life cycle of research, and this is a little schematic of, you know, the classic research planning and collecting and processing, which nobody follows, but at least makes a good graphic. And we use it in repositories and for exchange between repositories and services, for publication and sharing, and for reproducibility and provenance. And here's a couple of examples. So from Australia, we have the Paradisic repository for the Pacific and Regional Archive for digital resources in endangered cultures, which is particularly where Peter comes from. So we use it for collecting metadata and archiving it there. And we heard yesterday about the live publication from Mark, which uses Globus and RO crates to do a live living publication. So I put those up, but there's lots and lots of projects that use RO crates. And European Open Science Cloud, in particular, is adopting RO crate as a currency across the different services in the cloud. Now, there's more than one shape to a package. So RO crate is about packages. So what we have are what's called RO crate profiles. So these are community-defined content checklists, what you expect to see in that RO crate. It's basically just a set of conventions and the minimal required in order to be able to be an RO crate of that kind. So I mentioned workflows. We're using workflows in this trusted research environment execution space. We have all these different technologies: Workflow Hub, Nextflow, Galaxy, Life Monitor, which checks whether your workflow is being tested properly. All use RO crates, and they use workflow RO crates. So these are RO crates which have specific requirements about there has to be information about a workflow. And for workflow run RO crate, there has to be specific information about what the run was, i.e. the provenance, the history of the workflow that you ran, as opposed to the workflow that you could run. So we use for these duck typing. So duck typing is, if it quacks like a duck and it waddles like a duck, it's a duck. And that's what we use. So we don't do sort of type systems as you might in object-oriented environments. We use this duck typing, which is incredibly useful for classification, finding, but also for describing extensible descriptions. So you can have an RO crate which has workflows in it, an RO crate which has data in it, and I can send that RO crate to Mark, and he doesn't know about workflows, but he knows about data, so he just looks at the data bit and ignores the workflow bit. So it's very kind of flexible. And so for this, we used 5 safes RO crates. So the 5 safes RO crate collects all the metadata needed for the user, and what the job is going to be that you're going to query, and what are the pre-approved workflows that you've agreed with the TRE that you can run, and what's the metadata of the data set, not the data set itself, and the outputs, so the spreadsheet that you're going to get out at the end. And that is your object that we're going to now move around our trusted research environment and its analytical clients. So it's going to have the query, it's going to go through a whole set of processes in the TRE, where it will be reviewed and processed, and then out will come a disclosure-controlled result with all the creation details attached to the RO crate. So the RO crate is a package that basically accrues information as it goes around. So this is a high-level schematic of what happens, because we've implemented this. So we have a submission system with an egress system, of course. We have something that controls what's happening in the TRE with respect to the RO crate. We have the analysis execution. We have workflows and containers that have already been pre-approved and are in the TRE that can be spun up as part of it. And then we have the data use register outside of it, which says this is how it was used. So we've implemented all of this with all of our different partners and demonstrated that, not only does it work, but it's implementable by multiple different providers from multiple different TREs, from multiple different analysis platforms. And what happens is that the RO crate has not just metadata, but a process associated with it, that you check the metadata when you're checking into the submission. You validate when you're in the TRE, is this the right, you look at the project, you look at the person, and you say, are they allowed to run this data? Is this project approved? So all the metadata required to operate those processes are associated with this RO crate. So it's kind of, as I say, collects all this information as it travels around. So notably, SERP has implemented this, and SERP is the platform that implements the SAIL data bank, and I think it's widely used in Australia. I'm just looking at here, but yes, Yvette's just mentioned this. Now, SERP is run by Simon Thompson, who I love dearly, but frankly, he is, hard as nails, shall we say. He's not a developer that takes things and just does them because you tell them to do. He really doesn't. So it's really important that if somebody like SERP can do it, then we're onto something here. And what they're actually using here is a way of being able to use the metadata in the research objects to say these are projects and these are people and these are the TREs that are registered, and to synchronize that with the TREs when they get the call in order to be able to answer a query. So we're making things much more transparent. That's the key point I wanted to make there. And that transparency piece, I want to kind of emphasize a bit here, because the piece around trusted research environments and federation is not very much about technology and quite a lot about governance. And that's what the 5 safes and metadata is all about. It's about governance. Can I control what's happening? Can I see what's happening? What's the transparency piece? So all of our projects in HDR have to have a fully engaged public involvement and engagement process. So that means we have to be always with our patients and the public. And I noticed yesterday you had in the BOF the notion of the gift, and this is the gift from the UK perspective. In fact, we implemented this Trifix project as a sprint over 9 months, which is hard work to do that and really intense. And our weekly meetings were chaired by the patient advocate, which was a very interesting experience. It does stop you being super techie and does answer the question, why? Quite a lot. So this is all to do with communication and trust. And this is a shot from the screenplay of the video that we made for our patients and public that explains what an RO crate is. And it's a package that travels around. We also can use this metadata to streamline other pieces of governance. So other projects that were also funded alongside our Federated Analysis Sprint were projects around automated checking of disclosure control and outputs, automated checking of risk assessment, of actually trying to do the query. That all requires metadata, right? And these are processes and systems that have been developed by other people within HDR that can use the metadata framework that we've set up. And we can also, as I mentioned before, post the RO crate that we made for that particular query, for that particular project, for that particular setting into a data use register so people can see it being used. So to wrap up this piece, this is evolution in infrastructure. It's not a revolution for the existing platforms. And we really worked hard to reduce the burden of adoption by introducing transparent and reproducible analysis of the workflows, but incredibly important, accommodating existing TRE governance processes, make it 5 Saves compliant, be developers sympathetic to their stacks. So we didn't make you implement a new stack. You could use the same stack you always used. You just now mint and consume and annotate RO crates. And it's flexible because of this duck typing and descriptive approach. And it uses everything we used already exists. We didn't invent anything. But we're back to Peter. No, Gandalf. Is it a revolution rather than a evolution? Well, yes. The revolution isn't the technology. The revolution is the people. So our Oxford chaps are used to having an inside track to the data because they're from Oxford. And they don't see the point. But of course, if you're at the University of Bums on Seats, you do see the point of wanting to get access. They're very used to eyes on. Everything is eyes on. I want to see the data, not this notion of eyes off. The code sees the data. Trusted research environments have built a business around gatekeeping access, not around research. Their job is to gatekeep the access, not to manage research, and certainly not to operate in a multiple TRE environment, because their business is theirs. It's not to make everybody else be able to participate into a global research collective. And when you have these multiple TRE data sets, they don't belong to any one TRE anymore, so who looks after them? Right, so you get these orphan data sets. So at the moment, we're in artisanal wizardry. And what we need to move to is industrial routinary. I don't know if routinary is a real word, but anyway, I've made it up. Where we have much more transparent and independent reproducible science. So it's much less inside track, and here's a script that I have down my back pocket. Code-only access, so it's eyes off. Much more democratic approach, and to access. A kind of collective approach, which is a kind of theme of this conference, and retention of multi-TRE project datasets. We'll need to work out how to do that. So the issue here isn't technology readiness, it's project readiness, it's TRE readiness and willingness, it's patient and researcher readiness. So the technology development is only a small part, policies and processes, and the community culture and practices are the big things that we will have to drive in the next 4 years of our work in the trusted research, the federated analytics part of HDR UK. Of course, this doesn't speak about data harmonization. That has to be done. This doesn't speak to any of that. Somebody has to write and pre-approve the workflows. We still have to configure the project virtual machines as they step up, so we still have all the processes associated with that. And we really have to think about TRE business cases and deployment into TREs, not from the technical point of view, but from the social, business, economic kind of point of view. So what's next? Well, I'm, along with Phil Quinnan, I'm heading up the Federated Analytics work plan for Health Data Research UK, and we're going to take this approach And another one that I didn't have time to talk about called Teleport, which is to do with pop-up TREs within TREs. You could talk to me about that later if you want. And we're going to pursue this with partners, particularly actually in Oxford, funnily enough, because Aziz has just moved from Edinburgh to Oxford, and he's fantastic. And that's going to be particularly in the areas of inflammation and infection. The approach is going into SERP and therefore being rolled out into these other platforms. For example, the Alzheimer's disease data initiative and the dementias platform in Australia, actually. And of course, if you remember back in the day, I'm part of a big European network who's working in large-scale human data and moving data across borders, or rather not moving data across borders, moving analysis across borders, and data being retained in those national sovereignties. And there's a whole bunch of projects, including one called EOSC and Trust, which starts next month, which is to build a European network of trusted research environments, to develop a blueprint for trusted research environments, which actually HDR UK has already done, but we're going to do a bit more of it. And notably, in the 1+million genome initiative, which Elixir is really a major player in, it's got big projects, 17 different countries, sadly not the UK because we're not in Europe anymore for this bit. It's complicated. Sometimes you are, sometimes you're not. That's the way it works. But we're going to be using this technique as a use case in this very large approach, which uses federated EGA in order to be able to do federated analysis across different countries for genomic information, at least. But of course, HDR UK doesn't just work with genomic information, it works with all forms of health data, including administrative data. So we're going to be rolling out this approach into these European projects. So my take home is plumbing packaging revolutions, if you just remember that. Federating trusted research environments is inevitable, so the revolution is inevitable. I mean, Trotsky said a revolution is only possible when it becomes inevitable. That's your bit of, left-wing propaganda for today. But you have to respect the current stacks and the governance processes in order to get anywhere. And we streamline federation with this middleware plumbing, which we sometimes called underwear, because it's underneath everything else. So like software, underwear. Our researchers never see it. And if they do see it, something's gone a bit wrong. Or, yes, let's not go along that theme. So we're talking about metadata packaging and journeying of metadata and using workflow technologies. But I think the most important thing here is the metadata flowing. It's an evolution in technology and an advancement in FAIR, because all the metadata, all the things I was talking about, lead us to help better with FAIR, because FAIR is all about metadata and identifiers, actually. So we're able to make data more, or make our queries, make our workflows more findable, be able to improve accessibility by exposing exactly what you have to do and who has permissions and so on. But the revolution is in the practice. The revolution is dealing with proprietariness of TREs, not technically, but in the way they operate. And the kind of pace that we need to do, where we can't do everything with eyes only. I can quickly do your query, but then it takes 4 months to somebody to look at it before it's allowed to leave the trusted research environment. And that's what's happening at the moment. It takes months to get permission to have your project be given permission, and it takes months to get the disclosure control agreed, and it takes next to no time to stand up the VM and do the query. So that isn't the blocker. The blocker is the eyes, and that's all to do with trying to feed systems that can do that automatically, but trusted. And that, I think, is really why we essentially need metadata exposed in our TREs. I want to thank everybody for inviting me. I want to particularly thank Mark Stian Solares and Phil Quinlan. Stian is the lead of the RO Crate World, and Phil is my co-lead of Federated Analytics. And will be really annoyed I made all that jokes about Oxford, because it's really going to have to do lots and lots of calming stuff afterwards. And I also thank Gillian Beggs, our patient advocate, for all of her wonderful support of our work. And thank you very much. Thank you.
Good timing. I'm sure I'm not alone in saying it's always really interesting not only to hear about your work, Dr. Carole, but what the rest of the world do as well in eResearch. It's also, sometimes different, but most of the time also overlaps what we do here in New Zealand. We talked about the importance of people working together, and again, collaboration, ongoing theme. But thank you for also following the theme of keynotes, traveling halfway across the world, to be here today with us. I know New Zealand can learn a lot about trusted research environments and the safe havens that you went over, and we go through our own changes in Aotearoa, New Zealand. Thank you again, Dr. Carole.